All right, lesson 11.1, solving linear systems by graphing. So this is something we did right before we went on break, very quickly. If you're going to solve by graphing, one of the first things you need to do is make sure that your equations are in slope-intercept form. And what is a system? A system is more than one linear equation at a time. Systems can be more than any type of function or equation, but we're looking specifically at linears. So the solution is always where the points intersect. Now, you can also have occasions where they don't, and we're going to look at special occasions here as we go through this lesson. So, one instance is when the lines are parallel. Those never ever cross, so in that case, they have no solution. And again, that's our symbol for no solution. Another instance you could have is when the lines are basically on top of each other. They are on top of each other. In that case, the solutions, you might see this sometimes, all real, or it could also be infinitely many solutions. And I'm just using an abbreviation here. So the textbook continues with the different terminology here that you can use to describe systems. You can read through those and look at them. I'm not going to be as concerned with that as knowing how to solve. So right here we have two equations that are both in standard form. So the first thing they did is they graphed them. Now they graphed them using the x and y intercepts to plot 2 points and then draw the lines, and that's okay. Or like I said, you could put them in slope-intercept form. Now, the advantage to slope-intercept form is you can use the calculator. So that's what I'm going to do with the next one. So you can look at this example if you want to get better understanding of how it works. Now again, the solution is where the 2 points or where the two lines intersect or cross. In this case, which is the point 1, and then here we're at 4, so the point 1, 4. So how do you do this if you're going to use a calculator? All right, so I'm going to take the your turn problem here. First thing I want to do is make sure they're in slope-intercept form. So this one is not, so I'm going to change it. So I subtract x. So I get 2y is negative x plus 2. Divide everything by 2. Remember there's a 1 right here. So that now becomes y equals negative 1/2 x plus 1. So then you're going to graph. So I'm going to take the first equation. I'm going to graph it. So my starting point is negative 2. My slope is negative 2 over 1, so that means I go down 2 and to the right 1. Down 2 to the right 1, and then draw your line through those points. Then I'm going to take my second equation, negative 1/2 x plus 1, so that means I start at 1. My slope is negative 1/2, so that means I go down 1 and over 2, down 1 over 2, and then I'm going to draw the line through those points, and then you look for the point where they intersect. Now, here's the problem with doing it by hand. I don't have a ruler here, so my intersection point doesn't look real clear. So if you're doing it by hand, you definitely want to use a ruler. The other way you could do this is on the calculator, which we've done once before. Take y1, put in negative 2x minus 2, go to y2, and put in negative 1/2 x plus 1. You then want to go to your window. You want to set your window up to match the graph over here. So my x min goes to right here, which is at negative 4. My x max goes to right here, which is at 6. And my x scale, my x-axis, those are all going by 1s. My y-min, I look down here. My y-min is at -6. My y max, go to the top up here, that is at 4. And my y scale is 1s. Then I press graph. I should be able to see where they intersect. Then I go to second, trace, number 5, which is intersect. And then you're going to press enter 3 times. And then it should give your intersection point. And then when you do that, you should get x is -2, y is +2. Now, if you go back here to my graph by hand, you see it's really close to right there, but it's not exact, again, because I didn't have a ruler to use. So it's very important if you're doing it by hand that you use a ruler. So what I want you to do is go ahead and do question number 4 on your own. If you need to, pause the video and then check your answer. Okay, so you should have ended up with -2, 4. Now, the good thing about doing systems is you always know whether or not your solution's correct. Go back in, plug it into the equation. So if I take the first equation here, 4 is y, x is -2. So I get 4 is -4 plus 8. So 4 is, and that would give me 4. So that works. Always checking the other equation too. So negative of x is -2 plus y is 4 equals 6. So then you do change here. So you got 2 plus 4 is 6. So you get 6 equals 6, which is also true. So you know your solutions worked. So again, they give you some examples. These are special, so that means they're probably either parallel or that you get the same exact line. And this is another reason why doing slope-intercept form helps, because if it is a special occasion, you can tell immediately. So again, what I would like for you to do is try these two. I'm going to do them, and then you can pause the video, and then you can check them here in just a second. So this first one, if you take the second equation, work it out, put it in slope-intercept form like I did here, you see that the equations are exactly the same, which means if you graph them, it's going to be the same line. You would start at -2. This one's going by 2s here, so pay attention to your scale. Slope, you go down 1 to the right 1, down 1 to the right 1, and then draw your line. You're going to have the same exact line, which means it's infinitely many solutions. So again, putting it in slope-intercept form, you can tell if the equations are exactly the same, even though if you go back to the original problem, they don't look identical. So now try number 6. Okay, so at this point, if you solve the equations in slope-intercept form, you notice they're very similar, except their y-intercepts are different, but their slopes are the same. What's that mean? That means if you graph, let's say we graph the first one up here at the top. So if I graph it, I start at -1. My slope is up 2 to the right 3, and draw my line. Then I graph the second equation down here. Now I start at +1, use the same slope, up 2 to the right 3. And what do you notice? Well, when I draw my lines, they are parallel because they have the same slope but different y-intercepts. They'll never ever cross. What's that mean? They have no solutions because the lines are parallel. So then, what happens if it's not an exact point? And this is why you want to use the calculator. Sometimes when you draw them, they don't intersect at an exact integer value. So the calculator is helpful because, like right here, it's going to give you decimal numbers. So again, they give you some examples here. So all I'm going to do here is we're going to do problem number 7. I'm going to give you a minute to put it in slope-intercept form, graph them on the calculator, find their intersection, and let's see if we get the same thing. Okay, so if you did this, you can look at my work here as far as how to change the equations in slope-intercept form. But if you did it on the calculator, you should have ended up this point. It's like 2.580645 and -1.451613, which if you look at my graph is somewhat close to that. Again, it's a little off because I don't have a ruler, but it would be something you wouldn't be able to see anyway. So again, That's why the calculator is useful. Now, that all being said, you still need to know how to graph lines by hand and need to know how to do this by hand. So we go on with how do you do this if it's a word problem? And it's the same sort of thing. You see the equation here. You got to get it in slope-intercept form, put it in there, find where they intersect. Differences, word problems, first quadrant only. So the intersection would be here, and you got to pay attention to your window. And then they give you another example here, which we're going to skip. Well, actually, let's go ahead and do it real quick. At least get the equations. So we read here, Video Club A charges $10 for membership and $4 per movie rental. So Club A is starting point of $10 plus $4 per movie. You can use X here. A then would be like your Y. Video Club B charges $15 and $3 per movie. So B would be $15 plus 3X. They're your two equations. Graph them on the calculator, be able to graph them over here, find where they intersect. Now, where they intersect, remember, X is movies, and then Y here is your cost, how much it would cost. So for this particular lesson 11.1, you're doing page 485, and you're doing numbers 1 through 21 odd.